let's, which probably would be, let's talk about inheritance. So find some bad laws about inheritance, I guess. No, that's not in there. So, yeah. All right, here's the topics. What is inheritance? Calling the superclass, because some of you had talked to me about using the super declaration, overriding superclass methods, protected members, chains of inheritance. And chains of inheritance in many ways are a lot like we looked at in the jQuery class when you could use chaining something dot something dot something. So polymorphism, which is the ability to, for instance, if I wrote a method that was called speak, it would be implemented different for a human being as opposed to a dog. I think there's a law about that too, but I'm not sure. All right. Abstract classes and abstract methods, I talked a little bit about those last time. Interfaces. One thing about Java, how many classes can you inherit from? One. But you can inherit from multiple interfaces. So we'll talk about that at the end of the chapter. So again, you can read this. You use the extends keyword. We talked about that before. The general class is the parent class. The specific class is the child class. And as we talked about last time, it goes by many names. Here he uses a generic insect class and says that bumblebee and grasshopper would be examples. It's the is-a or is-an type of test that you use in here. And again, you can read these. And the thing it is or an, that's the parent. The author even mentions down at the bottom of the page. All right. Again, oftentimes they're either superclasses or base classes, and then the ones that are inherited are subclasses or derived classes, but they go by other names. I've mentioned some of those last time. So what they start with here, and it is pretty simple, is they talk about, okay, you've got a graded activity. And then later, because this kind of thing happens, maybe not here because I don't have tests, well, usually other than the math test, but they'll talk about having a test that's curved. And what they're saying is a test that's curved does everything that a test does, in addition it does something else. So that's how he's kind of getting into the subject here. So this is a UML diagram right here, and it says the top thing is the class name, graded activity. The middle thing is the data. Minus means it's private. Plus means it's public. So you've got a graded activity class with a double in it that's called score, that's private, and 3 public methods. Set score, get score, and get grade. All right. Notice there's no set grade. They're doing everything, probably at least, right inside of the get grade routine. And pretty much this stuff kind of dovetails with it. You know, you should be able to look at this code now, and there shouldn't be anything new there. Notice in the get grade, like I said, they figure it out and then return it there. There could have been a separate set grade and get grade if you wanted to do that. Then they've got a little demo on it where they let you come in here. 89 is a B, 75 is a C, etc. See, I should have run that program and then I should have keyed into your grades. But then you might not have liked, yeah, you might not have liked that though. So I guess they didn't do it with curve. They did it with a final exam. Okay, and you know this, that a lot of times, my daughter, reminds me I got to print out something for her. But with my daughter, she's taking a class at Rock Valley, and she didn't like the percentages. She just hates tests. So of course, 20% is for attendance and participation, 20% is for homework, and 60% is for tests. And she's reading that yesterday. She's like, why do they do this stuff? I don't know, because they can. I don't really know what to tell you. All right, I've given tests before. I used to give tests in all the classes. We were told to do that. And it was such a pain because you'd have to write something and you'd have to say, if you had a final and a midterm, okay, I've got to be able to test you on 9 weeks worth of material. All right, and there's a lot more than you probably think there is. Yeah, all right. And now today too, the other thing is, hell, you know, if I gave you 2 hours and I wasn't watching everybody, I'm not saying you do this unless I turned off your internet capabilities. Hell, you might be able to post something on Stack Overflow and get an answer by then, as far as I know. So again, a final exam extends a graded activity. What does that mean? That means that in addition to this stuff, which we'll look at in a second, Final exam has direct access to all three of these methods and indirect access to score. Final exam cannot change score directly, but it can change score through those methods. It can't access score directly because it's private to the graded activity class. All right? But in addition, as they just showed right here, final exam also has a number of questions, a points value per question, and a number missed. So in addition to having its own methods, it also has access to the three that we saw and these. Now, again, a final exam is a graded activity, but a graded activity isn't necessarily a final exam. So when you talk inheritance, it doesn't necessarily go both ways. In fact, normally it doesn't. Just like genetic inheritance, all right? Or just like regular inheritance. You know, I am my father's son, but he's not my son, type of an idea. All right. Now, there's probably laws about that too. All right. So they add that stuff here, and again, the big word is this one. It extends, all lowercase. Public class, new class name, extends existing class name. And then they go through it down on the bottom here of the page on, looks like 625, at least on the PDF here. And it's all the stuff that you've always been doing, except now we've got the extends word. When later on in the chapter, when we talk about interfaces, instead of using extends, you say implements. So you extend classes, you implement interfaces. Kind of easy, they're both I words. All right, implement, interface. And they're showing here, it says, because the final exam class extends graded activity, it inherits all of the public members. So it has access to all that stuff, anything that's public. But you'll notice everything that they show in here, all right, they don't show that score because that was private. All right, everything else that they show in here is public. And here's a demo of the final exam. Okay. You run this, what is it? How many questions? I can't even read that. Looks like 15. How many did you get right? Something like 8. Then you figure out what the final answer is. Now, one thing I didn't do the other day, don't want to get off on a tangent or anything, but if you remember the other day, and I guess it's out there on the P drive also, I think I've got everything caught up. All right. In fact, I just uploaded to YouTube the 2 lectures from this morning, but I think other than that one C lecture that I still have to fix, everything else I believe is up to date. But I wanted to show you this. This is that example that we looked at the other day, this PC class. And while I was going through it with you, I was thinking one thing that we should have done that we didn't do. If you remember from last semester that one of the things we did was we overrode the two-string method. We didn't do it on this program, and probably should have. It would have probably made for a lot nicer printing. You know, we could have standardized it or whatever that way. So probably should have done that and didn't. So. Now what they're showing here is just so you get the idea, so you have heard this, that is a UML diagram, and if you notice what it is there's an arrow, and it actually has significance. It's an arrow that's open. All right, it's not colored in, however you want to say it. And the arrow always points from the child to the parent. So this says final exam inherits from graded activity. All right. Now this is where they get into it, and I think, Doris, I think you were the one who had asked about this before. So let's just look at this program. It's kind of a dumb program. But notice they've got a class here that's called Superclass 1. It's got a constructor, and all it does is it prints out, this is the superclass instructor. Then they've got a subclass. And when you create the subclass, since it extends the superclass, all right, when you actually go to print it out, both of them print. All right, because the child, before it does anything, calls the parent's constructor. That's the idea of super. Because sometimes, again, in the example we looked at the other day, all right, I can even bring it back up, but we really don't have to. We did person first, and remember, the person had what? A name, address, and a phone number. And then we had an employee that had an employee number and whether or not they wanted to be on the mailing list. We called super first because the parent had to handle, because those are private data members, so the parent had to handle the name, the address, and the phone number. And you have to call super, has to be the first line of code in there. Other than blank lines or comments, you've got to do it first in this language. In fact, in most languages. Again, as I mentioned to you, inheritance does not work in reverse. For example, a graded activity object cannot call something, cannot call the get points each or the methods because they're a part of the final exam. So the parent can't take advantage of the stuff that the child did in addition to it, is what they're saying. So you use that super keyword in another example. First of all, I wish he'd put them all on one page. Second of all, I wish he'd have better examples. But he's starting slow. All right. So public class, super class 2. There's the constructor. So what is it doing? This is the super class args, no arg constructors. You know this already. Anytime you see a constructor like this that has just an empty set of parentheses, that's a no arg constructor. If you write no constructor whatsoever, one is written for you that looks like this one and has a curly brace like this and then just an ending curly brace with nothing else. Almost always that's not what you want. As soon as you write your own constructor, doesn't matter what it is, that no arg constructor the system writes goes away. So if you write your own constructor, and like if we had written that one constructor from the program the other day, and we'd only written one. Remember, there were two in there. There was a no arg, and there was another one where you passed in name, address, and phone number. If we only have the name, address, and phone number, and we didn't have the no arg, and we tried to instantiate, create that class with a no arg, when passing in nothing, we'd get an error message. All right, but it would work. It would work okay if we had no constructors at all that we created. Again, just a Java rule. Like I said, I find that example that they show in there to be a little more confusing than helpful. But you use super. If the parent constructor is expecting something, you've got to pass that up to it. All right, up the chain. If it's a no arg, it's just super with paren. So now they're adding to it, I think. Oh, this is where they're going to come in. They're going to create a rectangle class. We talked about this in an earlier chapter. So you should be able to look at this now, and this should make sense to you. But when you think about it, as an example, a square is a rectangle, but a rectangle is not a square. All right? So you could create a rectangle class, and you could base classes off of it. Probably what you'd do is you'd start much more generically, and maybe they'll get to that later in the chapter, I don't remember, but you'd probably create a shape class. And that would be abstract, meaning it's too generic to ever create one of them. And then rather than rectangle, right now, rectangle automatically extends or inherits object. But if you created a shape class, you could say something all shapes have in common, whatever it was. A mass, a color, whatever you wanted to put in there. And then you would say something like public class rectangle extends shape. Then later, you could go in and say public class square extends rectangle, type of an idea. All right. So they show that it's got two data members, both private, length and width. There's a constructor, there's a set and a get for each, and then there's a get area. And that's it basically right there. Then they're saying, well, a cube is just a special type of a rectangle. All right. And so it can do everything a rectangle can do. In addition, it'll have a surface area and it'll have a volume. So again, what I want you to get out of this is looking at that picture, automatically cube gets all of this stuff because it's extended from here. And cube can manipulate these, but it can only manipulate them through those. And that's a lot of what object-oriented programming is about. Is you set up an object-oriented hierarchy. All right? It might be several layers deep. It might be scores of layers deep if you've got a complex enough application. So again, what this says is, remember, a cube is a rectangle. This is saying call the rectangles constructor, and in order to do that, It needs a length and it needs a width, because that was two things that were shown in that constructor. I can, for the life of me, I always thought there are better examples than always using cubes and stuff like that, because most people don't deal with that kind of stuff on a regular basis. But almost any book I've ever seen that starts talking about this stuff, they all give almost the same examples. This is what I mentioned before. If the superclass doesn't have a no-arg constructor, all right, so it says here, recall from chapter 6 that Java provides a default constructor only when you don't provide any. This makes it possible, etc., etc. All right, so it says the rectangle class we just looked at is an example. It has a constructor that accepts 2 arguments. Because it doesn't have a no-arg, you can't call super paren with nothing inside, because there's nothing that maps up with that. All right. So they kind of summarize it here on, what, 639, and what they're trying to do is they're trying to show you again kind of what goes with what, or however you want to say this. Again, the following there you go. The following list summarizes what we've been talking about. The superclass constructor always must execute first. Why? Because typically it's doing some initialization that the child will need. That's why you have to have super first. You can write a super statement that calls the class's constructor, but only in the subclass's constructor. You can't call the superclass constructor from any other method. So you can't have a subclass call a method and have that method call super. You can't do that. If a super statement calls a superclass constructor, it must be the first statement, except for blank lines or comments. That's it. If it doesn't explicitly call it, as it says, Java will automatically call super just before the code in the subclass's constructor executes. But the only time you'd ever want to do that is if you had no arg constructors. Basically, you didn't even care about it one way or the other. Again, if a superclass does not have a default constructor and it does not have a no arg constructor, as it says, then a class that it inherits from must call one of the constructors that the superclass does have. The bottom line is, and you probably already figured this out, if you screw up, it isn't going to compile. Right? You got to follow the rules. All right. I believe last semester, and I'm going to put this up here, and you tell me if I'm right or wrong, okay? Not that. Last semester, I showed you something along these lines. All right, so looking at that, we're talking about overriding now. Do you know what that's called? True or false? We've got the exact same name for 2 different routines. True? But the signatures, in other words, what's in here is different between the two. Also true? All right. And the names don't mean anything. It's the types are different. All right. That's called overloading a method. Overloading. So you give 2 methods the same name, typically within the same class. That's overloading. So why did I tell you that? Because overriding is I create a method, so I come in here. Let's just pretend for a second. I'll leave this up here, but I'll move down a bit. So let's pretend that I create a class. So I've got here public class hello. A dumb example, but just so you see it. And I come in here and I've got ... So in other words, I've got the constructor and a bunch of other stuff. All right. So I come in here and I create a method. Public void my method. And inside of here, again, it does some stuff. I don't care what it does, but it does something. And I end that. Now, I come in here and I say public class goodbye extends hello, and I've got the same method. See how it's in two different classes? That's overriding it. So what that's saying is I define what the method does in the parent, but the child has something else to do with it. Does that make sense? All right. Now, what if the first thing, there's something special that happens in this one, and I want to do it in here? Remember, I can't call super because it's not a constructor. Does that make sense? But if I want to call my method, what I can do is not super, but super dot my method. It's a way of chaining, but what that's doing is that's calling the parents first. See, it's calling the parent method, and then it would do the child method. It's not an inheritance kind of thing. No, it's just what I'm telling it to do is I'm telling it to run this one first, then run this one. All right. So you can do that, is what I'm saying. You don't see it all that often, but it can be done. Yes. In order to be able to use super, it's got to be a child that basically that wants to call a parent. Now, let's say that would you agree that this isn't extending anything? Would everybody agree with that? Yeah. All right. I could have written this. In fact, I don't even need to write it. Remember, this automatically extends object. That's a special Java class. All right. But even if I didn't write it, even if I left it off, I could write it, but even if I left it off, if the first thing I write here is super, it goes and it calls the constructor for object. It does it even though I didn't ask it to. All right. But yeah, normally, yes, that's what it's associated with. So normally when you have super, what it is you've got a class that's extended another class. All right. And you want to make sure that it's got that the parent class has some stuff the child needs. It's usually initialization type of stuff. So you call super first. Did that answer your question? Yes. Yes. Yeah, so what he's saying is, yeah, I could have class 1 and then class 2 which extended class 1 and then class 3 which extended class 2, etc. You can get some really weird things too, where in some books will even say this. Well, sort of you're an aunt or an uncle type of thing, but you got to watch it when you're doing that, because by and large people who code like that don't know what they're doing, and those are kind of accidents that are waiting to happen. Inheritance really should go just down, or it should go up. Not like the jokes they make about the South, when you've got a really weird inheritance tree type of thing. But no, it should. It should just go straight down, and the inherited classes should be going back straight up. So it should be child, grandchild, great-grandchild, etc. There shouldn't be anything with aunts, uncles, and all this other stuff. Yes? Yes. Unless you overrode it, which you can do in there. Now, did you notice that when I overrode this? Look at the differences between these. In here, it's in the same method, so what's in here must be different. And notice the return type. So this whole thing is called a function signature, or a method signature. The signatures must be different between these. Everybody see that? All right. Again, it must be different when you're overloading. When you're overriding, the signatures must be identical. They have to be the same. Otherwise, the system doesn't know that you're even doing an override. And you're going to get an error message if you try to do that. So, I mean, I just showed it to you that way, but that's what they get into in here. All right. They'll say that, well, the way that you would, this is where they came up with that curve stuff. The way that you would score a curved activity is going to be different than the way you're going to score a regular graded activity type of thing. All right, so what they're saying is they want to be able to go in here and the set score method, all right, so this is kind of what I showed you before. Notice they want to go in here and do the raw score, and then they want to call superset score. But what are they doing in here? They're figuring out what you're using, since it's kind of a bell type of curve or whatever. they're figuring, okay, since this is kind of a curved activity, what's the curve going to be? You know, and if you don't know what they're talking about, it's sometimes if the whole class screws up on a test, what the teacher will sometimes say is, you know what, it was me. I didn't. Well, teachers never say that, but it was me, and really I made the test too hard, so I'm going to give everybody an extra 15% type of thing, because if I don't, I may have almost everybody failing. So that's curving. I mean, that's general, and I don't know about you. I did not have many teachers when I went to school that curved. All right. In fact, they would even talk about the old-fashioned bell curve, and what a great thing that was. All right. And you might have your own opinions on that. I always thought, possibly, was it a great thing? I'm not going to say one way or the other, but if it was a great thing, it was a great thing maybe as you're learning and you're younger. But in here, no. I want the curve to be, you know, if you go from 10 to 100, in an ideal world, you know, the curve, everybody's going to be up here, right? That's what you want. That's not how human nature works. If it worked like that, then you know, I had 10 extra people almost yesterday in this room for the JavaScript class. If it worked like that, I'd still have all those people next semester, and that's not going to happen. You already know that. Yeah. Well, after the one class, I'm not sure, so we'll see next week. What's that? No, I had 8. Yeah, there were the 4 that sat there. Tony, Kim, Mike, and Steve. All right. Stefan graduated from there. I also had one guy, Josh, who graduated in December. Keegan is only 2 classes short, but they're gen ed classes. Yvonne, she graduated. All right. So, yeah. You know, and out of you guys, too. You know, for example, I mean, you and Mark are both special cases. And I'm not trying to be funny. I'm really not. I just mean that you're taking stuff out of sequence, and you're not on a typical 2-year grid. All right. And as an example, because I keep picking on him all semester, like Travis is not. You're not in the C class, right? You're not. So he won't be graduating in May. You know, and that's just the way that it works. What they want us to start doing here at Blackhawk is start coming up with 3- and 4-year programs for people. Part of the problem is, I know you said this to me, Mike, that you said, geez, Jeff, by the time I graduate, everything I've learned is going to be all antiquated. And that always is in this kind of field. All right? That's always a big concern. I understand that. And I'll be honest with you. I think it's a bigger concern here than it is in Denny and Arinda's program. Because how much do the lands and WANs change over time? I'm not saying they don't, but not nearly to the extent that the stuff in this program changes. Yeah. Yeah. Right. Yeah. Right. I didn't see that article, but I saw a different one, and this actually scared me. All right, it was called the 10 Top Hot New Programming Languages to Learn. Not in 2014, but that was it. I didn't know 9 of them. I hadn't heard of 8 of them. All right, that kind of stuff scares me, but they're all offshoots of something else. You know, for example, more and more languages are coming out that allow you to use JavaScript as a server-side language. Angular and a lot of these other ones. And a lot of them are offshoots of those languages. You know, if you read it a little bit, you'll go, oh, this is just kind of like this. All right. Well, I know Ruby. Ruby is not exactly like anything I've ever used. But the thing with Ruby, what you do is, if you all know what scaffolding is, that you like when you're building a house. With Ruby, you do scaffolding, which basically means you kind of create a holder, you know, for your code, and then you do certain things. Then when you get it to a certain point, you remove the scaffolding. All right, type of an idea. And I had never, when I used that, I had never once seen a language that was exactly like that one. It's a neat language. All right, so this is where they compare and contrast overloading versus overriding. Again, hopefully, I did a good enough job explaining that to you where this, like I said, hopefully, where it makes sense. but it's different. The good news is when you start to talk about this kind of stuff, all right, overloading and overriding languages that provide it, they all work the same kind of way. Syntactically, they may be different, but conceptually, as far as what's going on, it's the same thing. All right. So how do you prevent a thing from being overridden? Remember that word? In the past, that word has always meant that it's going to be a constant. It's kind of what you're doing when you put final in front of the name of a method. You're making it a constant method. That's considered unbelievably poor object-oriented programming practice. Because if you put final in front of a method name, all right, then what you're saying is, I've written this method so well that it can stand the test of time and no one ever needs to add to it, or change it. You can also do this, rather than putting it in front of the name of a method like that, you can put final in front of a class even. All right, but you'll almost never see it. All right, so again, it's not with some of this stuff that you can't do it, it's just that you almost never see it done. All right. All right. Now, I think we've talked a little bit about this before. I could be wrong. So either way, I'm just going to throw this at you. All right. So I'm writing a program. Doesn't matter what it is. I type in this, public class my program. Okay? So I'm going to come in here and I'm going to include 3 variables. All right? You all with me? I'm going to include 3 variables. I'm going to say public int age equals 0. Public int height. I'm sorry. There's a reason I'm doing it this way. Private int height equals 55. All right. And then int weight equals 166. What I'm trying to show you here are the 3 different types. The 3 different types. All right. In fact, I'm missing one. So I got to add this line twice. So here I'm going to write protected. Int weight equals 166. Then on the next line, I'm going to come down and I'm going to write float salary equals 50,000. Okay? Now I've written that. Now I'm going to come down here, and there's some code in here. Everybody understands, right? When I go ... there's some more code in there. I'm not writing anymore, but there's more code in there, so there's other stuff. Then I come down here and I say public class your program extends my program. All right? And inside of this, I'm going to have some code. I don't care what the code is right now. There's a reason I'm doing this, and I'm showing it to you this way. All right? So then I'm going to come down, and underneath that, I'm just going to type in public class their program, and no extending. So do you understand? Right now, if we were to draw a hierarchy of what you see on here right now, it would be the parent would be my program, which would have a class that was called your program, and their program wouldn't be connected at all. It's like not even a relative. It's just another person or whatever. Does all that make sense? All right? All right, just so you know, you never do this. You never make data public. I've read things where they say, y'all accept it. No, you never make data public. If you do, I say you never do it, but if you do, age can be changed by either one of those classes because it's public. You see the danger in that? All right. This, it's private. So we probably have some kind of code in here that could handle that. But this, I can't access directly here or here. Directly. I can't. So the only way that I can legitimately change height is either through here or something that's in here. Does that make sense? This is in between those two. Now weight can appear on the left-hand side of an equal sign here or in here because it's a child. But it's not even known here. Does that make sense? This, it's not public, it's not private, it's not protected, so what is it? You actually know. It's package access. So if it's defined in the package, you know, remember those packages we've been creating all the time? That means it's available in the package. You almost never see that. All right. But Java set that up as a default, so if you forget to do it, the program will still run. It may run, and you may end up giving more access to somebody than you meant to give, but you can do it. So public means it's available, accessible to all. Private, only directly accessible inside of the class in which it's been defined. Protected, in the class it's been defined and any child classes, and nothing at all is the package access. Yeah. The only thing in here that you'd be able to use super in would be this, because that's a child of something. It makes no sense to use super here. No, it can't. Any other questions? I mean, it's fairly heavy stuff. It makes more sense sometimes to see it in code, and that's why I showed it to you that way. In fact, if we look in here, they give you a program that just uses protected. All right, notice for protected there's yet another symbol, a little hashtag. So they talk about package access, and this is the table that's on page, it looks like 655. So notice the default, that's package access. Accessible to a subclass inside of the package? Yes, in the package. Accessible to anybody else in the package? Yes. So it's public, but it's only public within that package. So if I created another Java program and or used another package in a huge program, that other program, if I didn't put public or private or protected, so it's they wouldn't know it. All right. Public, basically accessible to the world. Protected, inside of the yes, in the package. All right. And any other classes, that's not really said well. No, that's really anything else under the hierarchy. And private is, so you're going here from the most to the least restrictive. All right, is a good way to look at it. Again, default meaning package. Is it accessible outside of the package? No. Is it accessible to either a subclass outside or a class outside? No and no. Public, yes and yes. Protected, yes, in the same package. No outside of the package. That's not said well. Protected is not package access. It's access. So if you make something protected, just imagine again you're going down the hierarchy. So if my great-great-great-great-great-grandfather was a programmer and did that, it would be available to him, my great-great-grandfather, my great-grandfather, my grandfather, my father, and to me and to any of my kids. And their kids, etc. That's what protected is. All right. And again, private is the most restricted of all. So yeah, you know, we talked a little bit about chaining before. So it says a subclass can also inherit. This is the chains of inheritance first, but look at that. I actually took a class once where the guy went and drew a hierarchy of what he'd done at his job, and it looked really ugly. All right, I don't think he could have done it by hand. All right, I think he needed some kind of program because, for example, it was many levels deep, and one of these levels that was down here literally had about almost 100 things on it. And each one of those had one or two things from it. You can imagine how big it got, you know. He didn't even show us the whole thing. He showed us part of it. It would probably be about as big as this wall would be. All right. But if what you're trying to do is you're trying to do a problem that's very complex, you'll get stuff like that in a hierarchy that's that big. All right, here's pass-fail. Well, that's another kind of graded activity, right? But it's not curved. It could be, I guess, but it probably isn't curved. And it's probably not, it's not like our graded activity before, because our graded was 90 and above is an A, 80 and above is a B, 70 above is a C, 60 and above is a D, otherwise you fail. Here, it's going to be something along the lines of 60 or above you pass, otherwise you fail. So it can extend it so it can grab what it needs, but you're definitely going to do some overriding here. And you'd need to add something like this. What's your minimum passing score? All right. and they're keeping it real simple. So it's got everything that's public is directly available to it. All right, and then you've got your, just get your grade. Again, if it's greater than or equal to passing score, it's a P for pass, or else it's an F for fail, or however you do it. You know, plus, minus, however you want to set it up. Doesn't matter. And you could do the same kind of thing for an exam. So you've got a pass-fail activity, now you've got the exam. But notice one thing about this. Remember we had graded activity? All right. You can only, after the word extends, you can only put one class. You must put a class. You can't say public class, fail, or pass-fail exam extends and leave that blank. You can't do that. You say, well, what about object? No, you can't do that. But you also can't say public class, fail exam, extends, pass-fail activity, comma, some other activity. You can't do that. That's what we'll get to at the end of the chapter, because that's if you want to use an interface. Right? But when you run the programs, they're going to look very similar. But in the past, what they did was they said 100 questions. How many did you miss? 25. What's the minimum? Before they didn't say that. Otherwise, earlier, you would have gotten a 75, correct? And since that's greater than or equal to 70, and it doesn't meet the 80 criteria, that would have been a C. And if you say, who'd ever use this? Well, think about it. When you take your driver's license test, they pass you or they fail you, right? And it's based on a lot of things, but they don't say, well, sorry, Teresa, I got to fail you because you only, you needed this to pass. We only pass people who get an A and you got a B+. They don't do that. Or you could be like when I took my first exam and the instructor told me I wouldn't pass you no matter what. He said, you were terrible. All right. But I must have gotten better because I took it again the next week and the guy said, you're one of the better people who've taken the test lately. So, and also, you probably have all heard this, but again, a couple years ago when I renewed my license, they never renewed it. I brought it in there, and so I was driving without a license, which is against the law, for almost 3 years. And my insurance company found it out, and I was lucky I never got into an accident. It was the state's fault. And it actually had fired the person who did this because they were able to track it down and they knew who it was. But, well, I guess it makes for some very interesting times. So look at how when you start going through this, and this is only 3 levels deep. But this is why, not in this class, but if you're out on the job, that before you sit there, you're given some requirements. You sit and you talk about them with a lot of people. Customers, other programmers, etc., your boss, whatever it is. But then you develop something, and at a minimum, you're going to develop a way of doing it. Typically, you'll develop, I always have called them in the past, like the Cadillac, the Buick, and the Volkswagen kind of plans. The Cadillac will give you everything you want, but it'll cost the most, and it'll probably take the most time. The Volkswagen will probably get done the fastest, but it'll give you the least amount of stuff. That's why a lot of people settle for Buicks. Right, because it's something they can afford, but it's better than the cheapest type of thing, But the point is, what I'm getting to is, if somebody else looked at this same stuff, they could come up with a diagram like this that looked different, and theirs could be just as correct. That's one of the reasons, I'm sure you all probably know this, but that once you get into the coding phase, that's why you don't bring the customer in, because you're so far over their head that quickly. And they're, well, that sounds really good. And somebody else will come up with another, oh, that sounds good. Somebody else will come up with another idea. Oh, that sounds good. It's like, get the hell out of here, okay? You're more help or you're more harm than you are help. Right. All right, so that's how it would look as a hierarchical structure. So again, pass-fail activity is the parent of pass-fail exam. Graded activity is the parent of both final exam and pass-fail activity. And just so you know, too, this typically is referred to as like a leaf class, like a leaf node, meaning it doesn't have any children. All right. It doesn't mean that it couldn't have children. It means as of right now, it doesn't have any children. All right. As we talked about before, all classes, all right, either directly or indirectly inherit from object. But it doesn't make any sense. This is what I showed you. You could say public class, my class, or public class, my class, except extends object. I've never seen that in any code, ever. But you could do it. It wouldn't hurt anything. So that's actually how the hierarchy looks. And so why? Why object? Because that's got the stuff in there like system.out.println. And it's got all the stuff that most people would be most apt to use. You can actually go out to java.sun.com, go through the API listing, find the object class. You can find all the stuff that's in there. That just means that's all stuff that you can use, for lack of better words, as a freebie. All right, you don't have to do anything special in order to be able to use it. Okay. And that's, for lack of better words, that's what they're getting to right here. All right, this is a good spot to break because the next thing that we go through is polymorphism, which is one of the uglier concepts. It's 1:48, so let's come back, please, at 2 o'clock. All right, and we'll pick it up there. And we're making good time. You know, there's about 25 or 30 pages left in the chapter, so we should finish it with no problem.